Good day, ma'am. We are the group 3, and I'm going to present our laboratory 7, which is interfacing a tilt sensor on the Raspberry Pi. Introduction and background. Tilt sensor is an instrument that is used for measuring the tilt in multiple axes of a reference plane. Tilt sensors measure the tilting position with reference to the gravity and are used in numerous applications. They enable the easy detection of orientation or inclination. The tilt sensor produces electrical signals that vary with changes in angular moment. These sensors have a rolling ball, and this rolling ball is wrapped in conductive material. When the sensor is on and in the horizontal direction, the rolling ball falls downward, and an electrical connection occurs. And when the sensor is tilted, the rolling ball does not go down and there is no electrical connection. In this activity, a tilt sensor is to be utilized as a switch with some modifications and interface it with the Raspberry Pi. Objectives: to successfully enable the easy detection of orientation or inclination, to provide valuable information about the vertical and horizontal inclination of an object, and last is to explore and create a simple circuit design consisting of a tilt sensor and Raspberry Pi. Problem set. So the group is tasked with creating a tilt-controlled light display using Raspberry Pi and a tilt sensor. The goal is to design a system that changes the color of an RGB LED based on the tilt angle detected by the tilt sensor. So the setup. The RGB LED will be limited to two distinct colors, red and blue. The tilt sensor provides digital output corresponding to the tilt angle. The tilt angle should be categorized into two ranges, tilted and not tilted. Functionality. As the tilt angle changes, the color of the RGB LED should smoothly transition between red and blue. For example, when the system is not tilted, the RGB LED should emit a blue light, and when the system is tilted, the color should smoothly transition to red. Code. Write a program using the Tony to read the tilt sensor data and control the RGB LED accordingly. Implement a function to map the tilt angle to the appropriate color range for smooth transitions. Ensure that the color change is visually perceptible and readable, avoiding abrupt shifts. Experiment. Test the system by tilting it within the specified angle ranges and observe the corresponding changes in RGB LED color. And last is to document any observations regarding the responsiveness and accuracy of the tilt sensor. So here are the materials and equipment needed. So Raspberry Pi 4, tilt sensor, RGB LED, 220 ohms resistors, jumper wires, breadboard, and monitor display. Procedure. So to begin with, let's prepare the hardware before moving on to the programming phase. So start by assembling the components listed in the materials and equipment section. Next is let us proceed to connect the tilt sensor and RGB LED together with the resistors to their respective GPIO pins on the Raspberry Pi using jumper wires. Once the components are connected, we can now move on to the programming phase. Initially, connect all the essential cables, including the power source cable, HDMI cable for video and audio, and keyboard and mouse input cables in order to fully operate the Raspberry Pi. Allow a few seconds for the Raspberry Pi to boot up. After the boot up process is complete, the desktop interface will become visible. So to proceed, click on the Raspberry Pi icon located in the upper left corner, then click Programming, then click Tony. Now you will encounter the Tony ID interface. So to proceed, click on the file and then select New to begin the program. So once you have completed coding the program, click on Run current script icon to execute. So this will be the expected output of the circuit. So here is the circuit diagram of the circuit. And then here is the program. So the output, when the tilt sensor is not tilted, the LED will emit a blue light. And if the tilt sensor is tilted, the LED will emit a red light. So for the demonstration is we need a mini breadboard, a tilt sensor, an RGB LED, 220 ohms resistors, and jumper wires. So first is to mount the RGB LED pins on the breadboard. Connect the 220 ohms resistor to each of the RGB LED pins, excluding the GND pin. Connect the longest pin or the GND pin of the RGB LED. Then connect the tilt sensor with jumper wires. Connect a wire to the VCC pin of the tilt sensor. Connect a wire to the GND pin of the tilt sensor. Then last, connect a wire to the DO or the digital output pin of the tilt sensor. Next is to set up the tilt sensor for adjustable tilting. So we didn't mount the tilt sensor directly onto the breadboard so that it allows us to adjust the tilt sensor's orientation freely. After that is to connect the tilt sensor to the Raspberry Pi. So connect the VCC pin of the tilt sensor to the 5 volts or 5V pin on the Raspberry Pi. Next is to connect the GND pin of the tilt sensor to a GND pin on the Raspberry Pi. Then last is to connect the DO or the digital output pin of the tilt sensor to the GPIO 23 on the Raspberry Pi. Connect the red pin of the RGB LED to GPIO 17 on the Raspberry Pi. Next is to connect the green pin of the RGB LED to GPIO 18. Then connect the blue pin of the RGB LED to GPIO 27. And lastly is to connect the GND pin of the RGB LED to a GND pin on the Raspberry Pi. So after successfully setting up the circuit and running the code, we will proceed with testing. So if the tilt sensor is facing upward or not tilted, the RGB LED emits a blue light. Conversely, if the tilt sensor is tilted either right or left, the RGB LED emits a red light. So for the results and discussions, what observations did you make while testing the tilt control light display? So we realized that the tilt sensor has only two states, tilted and not tilted. So due to its two-axis nature, consequently, we simplified the RGB LED display to two colors, red and blue, aligning with these states. This, simplification improved system responsiveness and accuracy, ensuring smooth color transitions between the red and blue based on the tilt angle. So number two, how responsive is the system to changes in tilt angle? And did you encounter any challenges during testing? So during our testing, the initial observation was that the system was not responsive to changes in tilt angle. And then we fixed it by adjusting the sensitivity using the tilt sensor's built-in potentiometer. And after that, the system worked better and we didn't face any major problems. So the two-axis functionality of the tilt sensor effectively detected variations in tilt angles, providing corresponding electrical signals. We also observed that the tilt sensor operates in two states, tilted and untilted. So when the LED emitted a red light, when tilted, and blue light when not tilted. Number three, can you think of a real-world applications where a tilt control display could be useful? So one example of a real-world application could be useful in gaming devices. So in a scenario where playing games on phones, the tilt control feature adds an interactive twist to the gaming experience. instead of using buttons, the player can tilt the phone to control characters or actions within the game. This feature introduces a hands-on and mobile motion-based element, making the gaming experience more engaging and enjoyable. So, were there any challenges or unexpected results? We faced a challenge because we wanted to get the precise tilt angles from 0 to 90 degrees using the tilt sensor. However, the sensor only had two states, 0 or 1, like an on and off switch. This made it impossible to get the detailed results we were aiming for. And then once we realized and accepted this limitation, we adjusted our approach and things went smoothly. From there were no more challenges. So, summary and conclusion. This laboratory aimed to create a tilt control light display using a Raspberry Pi and a tilt sensor. The tilt sensor, designed to measure tilt in multiple axes, was modified to function as a switch and interface with the Raspberry Pi. The objective was to change the color of an RGB LED based on a tilt angle, with the system transitioning between the red and blue as the tilt angle changes. During testing, it was observed that the tilt sensor had only two states, tilted and not tilted, due to its two-axis nature. This led to a simplification of the RGB LED display to two colors, red and blue. The adjustments significantly improved the system's responsiveness and accuracy, ensuring smooth color transitions based on the tilt angle. Challenges were encountered initially, as the tilt sensor's binary nature hindered obtaining precise tilt angles. However, after adjusting the sensor's sensitivity, the system performed effectively without major issues. So here are the references, and that would be all. Thank you.